Building a shed is often described as a relatively contained project. Compared to a full home renovation, a shed appears limited in scope. It has a small footprint, a familiar shape, and a defined purpose. On the surface, that makes it seem straightforward. A few materials, a few tools, a weekend of work. But in practice, the complexity usually does not come from the size of the structure. It comes from how many separate decisions have to remain coordinated from beginning to end. A shed is not just a box with a roof. It is a chain of dependencies. Dimensions affect framing. Framing affects roof geometry. Roof geometry affects materials. Materials affect cutting order. Cutting order affects assembly flow. And once assembly begins, even small inconsistencies can carry forward into alignment issues, wasted stock, additional purchases, or stalled progress. That is often where the perception changes. What looked like a compact project starts behaving like a multi-stage system, not because the individual tasks are unusual, but because each task depends on the previous one being fully resolved. Most people approach this kind of project in a reasonable way. They look for a set of drawings, gather a materials list, estimate cost, and assume the rest will become clearer once construction begins. In many cases, they rely on standard plans, free diagrams, partial blueprints, or a combination of reference images and prior experience. That approach can work to a point. The issue is that many of these resources provide pieces of the process without resolving the full sequence. A drawing may show dimensions but not orientation. A materials list may identify quantities but not usage timing. A cutting list may exist without enough context to reduce sorting confusion later. A roof layout may appear complete until the framing beneath it introduces a mismatch. So the project does not usually fail in one dramatic moment. It becomes slower, less continuous, and harder to verify as it moves forward. This is part of why shed building often feels more complicated than expected. The friction is cumulative. It rarely comes from one impossible step. It comes from repeated interpretation, from unclear transitions, and from the need to make small judgment calls in places where the original information is incomplete. For beginners, that often appears as uncertainty. For experienced builders, it often appears as inefficiency. But in both cases, the underlying issue is often similar. The project requires more reconstruction of missing information than it first seemed to. That is also why common assumptions about difficulty can be misleading. People often assume the hard part is the physical labor or the technical skill of cutting and assembling wood accurately. But many delays begin earlier than that. They begin during planning, purchasing, and layout. They begin when the structure exists on paper, but not yet in a form that can be followed without ongoing interpretation. And that distinction matters, because there is a difference between having information and having resolution. A plan can contain measurements and still leave the sequence unclear. A diagram can look complete and still fail to show how one stage connects to the next. A list of materials can appear detailed and still create waste if the order, labeling, or intended use of those materials is not obvious when the build is underway. Over time, this has led to different formats of shed planning resources. Some remain minimal and blueprint-based. Others are more visual, more sequential, and more explicit about assembly flow, part labeling, and multi-angle references. The difference between these formats is not always about style. Often, it reflects a different response to the same structural problem: how to reduce interpretation between stages. One example of that type of format appears in large shed plan collections built around step sequencing, materials breakdowns, cutting references, and multi-view drawings. In that category, resources like My Shed Plans are presented not as tools for changing the project itself, but as ways of reducing the amount of unresolved information surrounding it. That does not eliminate the work. It does not remove the time, cost, or physical requirements of building, but it does reflect a broader recognition that the real complexity of a shed project is often informational before it is mechanical. And that is usually the point that changes how the project is understood. What first appears simple often remains manageable, but not because it is inherently basic. It remains manageable only when the relationships between planning, materials, cutting, and assembly are made clear enough to hold together across the entire build. Without that continuity, even a small structure can become difficult to track. With it, the project is still a project, just one with fewer unresolved gaps.